Hello everyone. Next problem in engineering mechanics, we are discussing about center of gravity. So determine the center of gravity of a plane uniform lamina as shown in figure. See here, one semicircular is there, one triangular and a rectangular is there. So extreme bottom we are fixing a reference axis which is AB. Extreme left we are fixing another reference that is CD. So according to these reference point, what is the X bar and Y bar that we are going to find out. So the given plane figure consists of three types of simple geometric figures. So which one? First one is the rectangle one, second one is semicircular, and third one is the triangular. So let X bar is equals to distance of CG of plane lamina from the axis CD. X bar is the horizontal distance of a center of gravity from the line CD, from the reference line CD. Next one, Y bar is equals to distance of CG of plane lamina from axis AB. So bottom, extreme bottom, we considered another reference axis which is AB. From that AB, Y bar is the vertical distance of center of gravity. Next, we divide the whole circle, whole plane figure into three types. First one is the rectangle. Let us find out the rectangle area, which is small a1 is equals to area of rectangle, which is length is 10 centimeters and height is 5 centimeters. So total 50 centimeter square. Next area is semicircular. So A2 is equals to area of semicircle pi r square. So radius is 2.5 centimeters. Radius is 2.5 centimeters. So that total area will become 9.82 centimeter square. Next area of triangle, which is half BH. Base is 5. Base is 5. 2.5 this side, 2.5 that side. Both combine 5 centimeters width and 5 centimeters height, which is 25 divided by 2, which is 12.5 centimeters. Next, we need to find out the distance of CG of the rectangular one from the line CD. Distance of CG of the rectangular line from the line AD. So we also know that rectangular center of gravity distance is D by 2 or B by 2. So distance of CG of area 1 from the CD axis is 10 divided by 2. But the reference axis for the rectangle is at a distance of 2.5 centimeters from the whole lamina reference axis CD. So that we are adding another 2.5, which is 10 divided by 2 plus 2.5, which is equals to 7.5 centimeters, which is X1. Next thing, X2. X2 is the distance of CG of area 2 from the axis CD axis. So this is a semicircular. This is semicircular. Semicircular center of gravity distance from the center is 4r by 3 pi. Now we are seeing from the edge, so that we are using r minus 4r by 3 pi. R is 2.5 centimeters and minus 4 into 2.5 divided by 3 pi, which comes to 1.44 centimeters. Next one is X3. X3 is the distance of CG of area 3 from reference axis CD, which is, so here 2.5, another 5, here again 2.5, which is, I think overall comes under to 10 centimeters. Okay, this is the X bar. Horizontally we have find it. Next one is vertical. So let us comes to the rectangular. So here y1 is d by 2, which is, what is the d means 5 centimeters. So that 5 divided by 2, which becomes 2.5 centimeters. Next one is y2. Y2 is equals to distance of CG of center of gravity of area 2 from the axis AB, which is the radius 2.5. Next one, y3. Y3 is equals to distance of center of gravity of area 3 from the axis AB, which is 5 plus h by 3, 5 plus 5 divided by 3, which is equal to 6.67 centimeter square. So what we have find out is A1, A2, A3, X1, X2, X3 and Y1, Y2, Y3. To find the distance of center of gravity of a whole plane lamina from the axis CD, X bar is equals to formula A1 X1 plus A2 X2 plus A3 X3 divided by A1 plus A2 plus A3. Therefore, A1 is 50 centimeter square, X1 is 7.5 centimeters, A2 is 9.82 centimeter square, then X2 is 1.44 centimeters, A3 is 12.5 centimeter square and X3 is 10 centimeters divided by A1 plus A2 plus A3, 50 plus 9.82 plus 12.5, which comes to X bar is equals to 7.11 centimeters, which means from the reference line CD, the center of gravity of this whole plane lamina lies at a distance of 7.11 centimeters. From this here to here, 7.11 centimeters. Next one is we need to find the vertical distance of center of gravity from the reference axis AB, which is equal to Y bar is equals to A1 Y1 plus A2 Y2 plus A3 Y3 divided by A1 plus A2 plus A3. So A1 is 50 centimeter square, Y1 how much we got is 2.5 centimeter, A2 is 9.82 centimeter square, Y2 is 2.5 centimeter, A3 is 12.5 centimeter square and Y3 is 6.67 centimeters divided by A1 plus A2 plus A3, which is 50 plus 9.82 plus 12.5, which is comes to 3.22 centimeters, which means the center of gravity of this all plane figures, three plane figures, rectangular, semicircular and triangular, lies at a distance of 7.11 centimeters from the line CD and 3.22 centimeters from the reference line AB. So this is the center of gravity of the given plane figure. So the distance of center of gravity of the plane figure at a distance of 7.11 centimeters from the axis TD and 3.22 centimeters from the axis AB. So let us continue with the second problem. Here what happens is the reference axis, in this problem the reference axis are already determined by the questioner only. So determine the center of gravity as shown in figure by taking the moment of area at AA axis and BB axis. So reference axis they only already fixed. If not fixed means what we will do, we will take extreme left and extreme bottom, we will take it as a references. Okay, here also first one is we are dividing it into three parts, three plane figures, three geometric plane figures, 1, 2 and 3. First one is the rectangle, second one is the right angle triangle, third one is the semicircular. So let us find the X bar and Y bar. So let X bar is equals to the distance of CG of area from the AA axis, from the AA axis. Next one, Y bar is equals to distance of CG of area from the BB axis. So here we are finding out area, X bar and Y bar. Let us find out for the number 1, which is rectangle. Area of rectangle is B into D, which is 12 into height is 6, 12 into 6, which is 72 centimeter square. Next up we are going to find rectangle, which is half BH, half into 12 into height again is 6, which is 36 centimeter square. Next semicircular area, pi r square divided by 2, which comes to 18 pi. Next X bar. So this is rectangle, overall length is 12, so formula is B divided by 2, 12 divided by 2, which comes to 6. Next X bar of the triangle, from the apex point, if we see from the apex point, center of gravity is at a distance of 2h by 3. If we see from the adjacent side, it will be h by 3. From here we are seeing from adjacent side, so that it becomes h by 3, which is 12 divided by 3 is equals to 4 centimeters. Next is semicircular. See, in previous problem in semicircular we are considering it from the arc side we are considering, so that it became r minus 4r by 3 pi but here we are considering it from the center of the semicircle, so that the formula becomes 4r by 3 pi, which comes to 8 pi. Next step is in y bar. In y1, y2 and y3 we are considering from the BB axis. So y1 will become 6 divided by 2, which is 3. Next one is, here again 6 is there, 6 plus, here also we are seeing from the side, so side we are seeing means h by 3, which is 6 by 3. 6 plus 6 by 3 becomes 8 centimeters. Next it is semicircular is there, so mirror image is there, so that it becomes total length divided by 2, which is 12 divided by 2, 6 centimeters. So after substituting everything, we will get the x bar and y bar. X bar is equals to a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3. Next, if you want to find y bar, is equals to a1 y1 plus a2 y2 plus a3 y3 plus a3 y3 divided by a1 plus a2 plus a3. So like that we can find the x bar and center of gravity of distance from AA axis and BB axis. Okay, we will see it in the next problem. We are going to see moment of inertia.